This is Chapter 5.1, Exercises 36. This section 5.1 has to do with simplifying trigonometric identities, and we're going to work out the odd number problems 31, 33, and 35. The technique we're going to use in these problems is to take identities to change expression in terms of sine and cosine and simplify. And in this first problem, we have a cotangent x, and we're going to use the reciprocal, actually the quotient identity. Cotangent theta equals cosine theta over sine theta. And also we have a quotient identity, which is cosecant theta is equal to 1 over sine theta. So let's go ahead and rewrite this cotangent x as cosine x over sine x, and then we have minus cosine cubed x, and we're going to rewrite this cosecant x as 1 over sine x. Now, a common factor between these first two terms is cosine x. So we're going to factor out cosine x, and cosine x times what equals cosine x over sine x? Well, that's going to be 1 over sine x. And then we have minus, and cosine x times what equals cosine cubed x? Well, it's going to be cosine squared x. And then we have times 1 over sine x. And so now we're going to rewrite this expression as a common denominator, because over the common denominator we have of sine x. So we have cosine x times, now we have the numerator 1 inside parentheses cosine squared x, and that's going to be over our common denominator of sine x. And there's a Pythagorean identity, which is sine squared theta plus cosine squared theta is equal to 1. And if we subtract cosine squared theta from both sides of this identity, we have sine squared theta equals 1 minus cosine squared theta. And so we can take this sine squared theta and replace 1 minus cosine squared theta, where we've been working. So we're going to have times, we have cosine x times, we replace 1 minus cosine squared x with sine squared x, and we have over sine x. And working to the right now, we have cosine x, and cosine squared x over sine x equals sine x. And removing the parentheses, we have cosine x times sine x. Cosine x, sine x. Okay, there we go. And this will be our simplified version here, cosine x, sine x. Next odd number problem, 33. We have 1 minus cosine x over tangent x plus sine x over 1 plus cosine x. Now eventually we're going to take the identity, the quotient identity, tangent theta equals sine theta over cosine theta, but we're going to simplify first before using this, the quotient identity. And so we're going to get a common denominator in these first two terms. In our common denominator, I put abbreviate CD, is going to be tangent x times quantity 1 plus cosine x. Okay, so we're going to rewrite as 1 minus cosine x over tangent x. And then what do we need to multiply by to get a common denominator of 1 plus tangent x times quantity 1 plus cosine x? Well, it's going to be 1 plus cosine x over 21 plus cosine x. And I'm going to rewrite, I'm going to put parentheses under this first 1 minus cosine x. So that's this first part. And so the next part we take is sine x over quantity 1 plus cosine x. And what do we multiply by to get our common denominator? Well, it's going to be tangent x over tangent x. And so now we have our common denominator, and I'm going to rewrite that common denominator as tangent x times quantity 1 plus cosine x. And in the numerator, we're going to take this quantity 1 minus cosine x times quantity 1 plus cosine x, and this is a difference of squares. And so this is going to be these terms, these binomials multiplied together as 1 minus cosine squared x. And the minus cosine x times 1 and the 1 times cosine x will cancel each other. So this would be the multiplication of this quantity 1 minus cosine x times quantity 1 plus cosine x. And then we write plus sine x tan x, tangent x. So there we have it. Now, what we're going to do is take, if you recall from that last problem we did, problem 31, we had that sine squared theta plus cosine squared theta is equal to 1, and we subtracted out cosine squared theta from both sides. So we had sine squared theta is equal to 1 minus cosine squared theta. So we're going to use this identity to rewrite this expression, this 1 minus cosine squared theta. We're going to, cosine squared x, we're going to rewrite as sine squared x. So we have sine squared x plus sine x tangent x over they're a little more horizontal, it's a little better, tangent x over 1 plus cosine x. Now, what we're going to do is use our quotient identity and rewrite tangent x both in the numerator and denominator. So we have in the numerator here sine squared x plus sine x, and tangent x we're going to rewrite as sine x over cosine x. Sine x over cosine x. There we go. And in the denominator, we have tangent x we're going to rewrite as sine x over cosine x times quantity 1 plus cosine x. Okay, I'm going to come up here to the right, up and to the right, and we're going to take what we have in the numerator is we have this sine x times sine x. The numerator becomes sine squared x. So we're going to rewrite this sine squared x plus sine squared x over cosine x, and in the denominator we're going to multiply through this. We take this sine x over cosine x plus we have sine x and we have over cosine x times cosine x. Okay, just read that without parentheses. Okay, so now we're going to take this. We have in the numerator sine squared x times 1 minus 1 over cosine x. And in the denominator, we're going to go ahead and factor out a sine x from, first of all, we have that cosine x over cosine x cancel each other. And we're going to take a sine x factored out. So we have sine x times, this is going to be 1 we have 1 plus 1 over cosine x. Well, 1 over cosine x is secant x, but we don't even need to simplify that because we have one thing over the other canceled to equal 1. So what we have left is we have sine squared x over sine x, which simplifies to just the sine of x. So this will be our simplification, sine x, of our original expression up here. That's a significant simplification. Next and last on the problem we're going to be looking at is cosine x, cotangent x over secant x plus tangent x plus sine x over secant x minus tangent x. And our common denominator we're going to get by multiplying the two denominators together. So we're going to get secant x, secant x plus tangent x times quantity secant x minus tangent x. And so writing this out, we have cosine x cotangent x over quantity secant x plus tangent x times, we're going to have quantity secant x minus tangent x over quantity secant x minus tangent x. And we have plus, we have sine x over quantity secant x minus tangent x times quantity secant x plus tangent x over quantity secant x plus tangent x. And so now we have a single common denominator, which is, I'm going to write the denominator first. We have secant x plus tangent x times quantity secant x minus tangent x. And in the numerator, we have cosine x times cotangent x times secant x, and we're going to have minus cosine x cotangent x, cosine x cotangent x, and tangent x, plus, and now we're coming to the right here, sine x times secant x. So we have sine x secant x, and then we have plus sine x tangent x. So that's quite an array. Well, in the numerator, or in the denominator, we're going to multiply quantity secant x plus tangent x times quantity secant x minus tangent x. So we're going to get secant squared x minus tangent squared x. And in the numerator, what we're going to do is rewrite everything in terms of cosine x and sine x. So this cosine x we write as cosine x, and then we're going to have cotangent x, which is going to be cosine x over sine x, and then we have secant x we're going to rewrite as 1 over cosine x. And we're going to have minus the second one here, cosine x, and cotangent x, which is cosine x over sine x. And then tangent x we rewrite as sine x over cosine x. And then we have this plus sine x, and the secant x we rewrite as 1 over cosine x. And then this last one we have is plus sine x times tangent x, which is sine x over cosine x. Okay, now we're going to start being able to really simplify this thing. And to do that, one of the Pythagorean identities is tangent squared theta plus 1 equals secant squared theta. Well, if we subtract tangent squared theta from both sides of this identity, we have 1, it's equal to secant squared theta minus tangent squared theta. So what that means is we can rewrite this denominator of secant squared theta minus tangent squared theta as 1, which I've done there. Okay, and now we're just going to cancel and simplify in the numerator. We have cosine x over cosine x in this first expression. In the second one here, we have cosine x over sine x times sine x over cosine x, both of those. cross multiply or cross multiply together equal 1. And then this next one, this third one, we have sine x or cosine x, which equals, that's going to be equal to tangent x. And this last one, we have sine x times tangent x, it looks like, on this last one. So let's go ahead and write this out. We have tangent x. Oops, I want to get that blue. We have tangent x, and then we have minus cosine x. Excuse me. The first one there, I said it was tangent x. That's going to be cotangent x. It's cosine x or sine x. That's going to be cotangent x. And then we have minus cosine x. And then this next one we have is plus tangent x. And this last one we have is sine x times tangent x. And I think that's going to be most of it. And just rewriting, instead of the over 1, we'll just rewrite it without the over 1. So we have cotangent x minus cosine x plus tangent x plus sine x tangent x. And really, that should be it. So it actually is a simplification from the original. So good luck in using these trigonometric identities to simplify, and thanks for viewing.